Hello. Am I audible?
Yes, sir.
Yes, sir.
So, good evening to all of you. Yeah, I think CT session is going on, right? Is it about to finish or so is it about to finish or it's still going on? Am I audible, right? Hello.
Yes, sir, you are
Yeah.
audible and CT session is still going.
It's okay. So someone messaged not finished. Okay, no problem. Okay. So what we can do? We can wait for some uh, uh, couple of minutes. Then we can start. Will that be all right? Meanwhile, how many of you covered the content of week 6?
Start.
Yes, no. You can raise your hand having some idea. Okay, so Preeti has finished. What about this? Are you still watching or so accordingly we'll decide the agenda of the session. Okay. So if you guys have watched, then we can take the doubts directly, or else we can discuss the concept first.
Yes, sir,
Yes, sir.
please.
Doubts.
Sir, please discuss the concept.
Sir, discuss the answer.
Concept wise, right?
Yes, sir.
Okay.
Yes, sir. Please.
How
Sir, and if we have doubts, then can we ask those as well?
you can ask, or else from week 6 or week 5.
No, sir, from earlier weeks, if I could post those in the chat, would you answer?
Uh, okay, don't have any problem. So what we can do, how many of your doubts from week 5? Any questions from week 5? Or is it clear week 5?
No, sir, not week 5.
Week 6. So you have doubt from week 6, right?
No, sir, actually, I have doubts from earlier weeks, but I was not able to join earlier meetings. So, is there
Earlier
a way
week
that
means
I can
you
ask
mean,
those?
okay, okay. So earlier means you mean from week 4, before week 4, right?
Okay, sir. Yes,
Yeah,
sir.
that okay. Okay, so no problem. We can discuss at the end of session, no problem. Because week 4 is
Yes,
something
sir. Sir, I just have
hmm.
Sir, there are just three questions which I were not able to solve, so I will post them in the chat and then you can answer them anytime in the meeting, during the
uh,
meeting or after this.
no problem. So it's from practice graded or where?
Sir, practice from practice
Okay, okay,
assignments.
no problem, no problem. We can discuss it.
No
Okay,
problem,
what
no
you can
problem.
do, we can discuss at the end of the session, or else
Okay, sir.
you can post on discussion forum also. That will be also right. Okay, no problem. Okay, we can discuss because
Okay,
today I'm planning to discuss the concepts of week 6. Okay,
okay, sir.
fine. Okay, okay. So is there anyone who has doubt from week 5 question, or should we start with the concepts of week 6?
Yes,
Yes,
sir,
sir.
start with P6.
Okay, then let me share my screen. If you will have doubt. then we can discuss. Okay. So can you see my screen? No?
Yes, sir, visible.
Yes.
Fine. Okay. So okay. So in week 5, hopefully you have seen that, right? Two major concepts, right? In week 5, you guys have seen two major concepts. First one is counting principle, right?
Yes, sir.
Correct. And second one is factorial. Okay. So these were
Yes,
the
sir.
two main topics of the week 5 content, right? So in counting principle, you know what is the like agenda, right? Suppose I have one event, right? Let's say event A, which can occur in n1 way, for example. Okay. And there is another event B, which can occur in n2 ways. Okay. Then total number of ways in which event A or B can occur in how many ways? N1 plus.
And two.
Okay. And another case was in when A and B can occur both. So there is difference or and A. So when A and B can occur, so there are N1 into N2 ways, right? So for example, you can see, let me take suppose you went to a shop. There are some, let's say uh, three, let's say milk chocolates are there, okay, and two dark chocolate. Okay. So suppose I'm asking in how many ways you can purchase either a milk chocolate or okay, let me write here three milk chocolate, okay, and two dark chocolate. Okay. So let's see. A question is suppose I'm asking in how many ways you can purchase either a milk chocolate, okay, or a dark chocolate. Okay. So that means what?
Three
See,
plus
if you
two,
see,
five.
I can purchase either, let's say, M1, M2, M3. I mean, these are the three milk chocolate, and D1, D2, these are the four dark chocolate, right? So I can purchase in how many ways? 5 ways, right? I can purchase any of these five, right? So by the formula, we can see, so this is the N1, and this one is the N2. So N1 plus N2, if you see, I'm asking or, I'm not asking and. So it will be 3 plus 2, which is same as the 5. Yes or no?
Yes.
Correct? Suppose question is I'm asking you have to purchase a milk chocolate and a dark chocolate. So that means how many ways I can purchase? By the formula N1 into N2, that means 3 into 2, that means 6 ways. What are those 6 ways? How it came, you can see. So see, if you see in how we have to purchase a milk chocolate and a dark chocolate. That means I can purchase a milk chocolate and a dark chocolate, right? Then a milk chocolate, second dark chocolate, yes or no? Then milk chocolate, dark chocolate, milk chocolate, dark chocolate, milk chocolate, dark chocolate, milk chocolate, dark. If you see, there are total 6 ways in which I can purchase a milk chocolate and a dark chocolate. Yes or no?
Yes, sir.
Yes,
Correct?
sir.
Yes, sir.
So this
Yes,
is
sir.
something we can apply the very basic fundamentals of the counting principle. Now let me move the now. So you know the factorial, how to represent the factorial. Suppose I'm writing n factorial, so this is something I can see n1 into n minus 1 into n minus 2 into up to 3 into 2 into 1. So this is something factorial we can represent. So let's move to the week 6 content. Okay. So what is the week 6 content actually? So we'll now start with the concept of week 6. Okay. So I will discuss the concept along with the example. Okay. Then we can take the doubts after that. Okay. Now, so very first thing is called permutation. Okay. So in week 6, mainly you will be saying permutation and combination. So sometimes people have no doubts when to use permutation, when to use combination. All those things we'll see. First of all, let me just clarify some formula and all regarding permutation. Okay. So what in permutation, what we are saying, we are observing the number of possible permutations, okay, of small r objects, okay, from a collection of n distinct object, right? So there is one formula which can be given by. So suppose I'm saying you have to do the permutation or arrangement of r objects out of n objects. Then for the first object, in how many ways I will be having n ways, right? And for the second, I will be having n minus one. Yes or no?
Yes, sir.
For the third, n minus two, and up to n minus, you can see r minus one. Yes or no? So basically it will be n into n minus 1 into n minus 2 into up to n minus r plus 1. So if you see in the numerator part, what I can write, okay, so can you tell me in the numerator part, if I want to, so there is one formula, what is that? So if you see, can I write n into n minus 1 up to n minus r plus 1, then I can proceed like this, n minus r into n minus, like it will be n minus, see here r minus 1 is there, then n minus r, then r plus 1. So it will be n minus r minus 1 up to 3 into 2 into 1. Can I write? I can multiply or not? Same thing, I can divide this whole quantity, that means n minus r into n minus r minus 1 up to 3 into 2 into 1. Are you getting my point? This quantity I can divide and multiply. Yes, no, are you getting?
Yes, sir.
Yes, sir.
Okay. So if you see in the numerator part, what is the numerator part?
N minus R factorial.
Why n minus r? In the numerator part, it's starting from n
Well,
and it will,
And
N
factorial.
n
factorial.
and numerator part, sorry, denominator part, it will be n minus.
N minus r factorial.
So this is something formula of permutation. We are representing it as NPR, and so this formula came from here. So it will be n factorial divided by n minus r factorial. Similarly, you if you apply the NP0, you will get 1. Okay, and for the NP1, just if you put the values and all here, so you will get for NP1 it's a n. Okay, basically these are the some special cases. Similarly, what about NPN? N factorial, right? For NPN, it's n factorial.
Sir,
Yes.
why 0 factorial is 1?
Okay. So why 0 factorial is 1? We are not going in that derivation and all. Okay. But you can simply think. So 0 factorial means what? Okay. 1 factorial means what?
1,
I'm asking about
if
meaning.
I'm not
Meaning.
wrong. Meaning,
Huh.
like number of mm, possible permutations without repetition.
Number of.
Sir,
Number
1
of
into 1.
possible ways of choosing n objects without repetition.
See, actually, see, if you talk about 0 factor and all, okay. So let me just give you some rough idea. Actually, factorial, if you see, no, so factorial is nothing but just it's the means product of all the positive numbers less than that equal less than or equal to that numbers. Okay, but can you tell me before for the zero, is it possible?
No, not
So,
possible.
so, so there is one of the reason we are taking 0 factorial as 1. Okay, okay.
Sir,
So
can you
let's
please the last one?
sorry.
Like uh, n permutation n is equal to n factorial.
This one. So you have to just apply the formula. If you put here, right, NPN. So that means it will be n factorial and n minus n factorial. and we'll get n factorial divided by 0 factorial. 0 factorial is 1, so it is n factorial. Okay, just substitute the values in this formula. Okay, so this is the formula of permutation. Okay, but thing is that when to use permutation, right? Is that question or not? That might
Yes,
be
sir.
interesting question, right? But sometimes see, you know the permutation, you know the combination and all. Okay, but when to use? Okay, let me give you the idea of combination also. Then I will sorry, one another formula permutation. Then I will give you the idea about combination formula also. Okay, so there is one formula for permutation when objects are repeating. I mean, when repetition is allowed. This Kiran, could you please mute yourself? There is some background. Yeah, thank you. Okay, so when repetition is allowed, so what I mean by repetition is allowed? Suppose I am okay. In how many ways I can do the permutation of R objects? Okay, when repetition is allowed, that means so for the first element, in how many ways out of n? In how many ways I can in for the first object? How many options we have? N, right?
Yes, sir.
For the second,
And
N minus.
no, its repetition is allowed.
Yes, sir. N.
and
Then for third,
and
up to n, right? So this is for r times, right? So basically it will be n raised power r. So this is one formula. Okay, let me take one example. Hopefully that will give you some idea. Okay, suppose I'm saying you have to create a password. Okay, let's say a 4-digit password. Okay, by using uh digit 0 to 9, and I'm saying repetition is not allowed. I'm mentioning. Okay, if I'm saying repetition is not allowed, that means okay. So for the first digit, second digit, third digit, fourth digit, we have to create this all the passwords. First, okay. How many ways we have for the first digit? In how many ways I can fill?
10,
Yes.
10, right? And for the second, see
Nine.
here I'm
9.
mentioning 10, so
9,
it's a multiplication. For the second, it's 9 digit. For the third,
8.
for the fourth,
7,
correct? Whatever the answer is there, right? If I'm saying, let's change the scenario, I'm saying repetition is allowed. So what do we mean by repetition is allowed? Means I can repeat the number. Okay, if I can repeat the number, that means for the first place
10 to
I
the
will be
power.
having all 10. I can repeat the number, means for the second again I will be having 10. For the third again I will be having 10.
Yeah.
Okay, this is 10 raised power 4. So these two are the scenarios, right, where we can use this thing. Okay, so let's talk about permutation itself, right? When to use this permutation actually. So main thing is, if you can see, I use the permutation in case of password. Okay, password means suppose I'm saying. So one basic thing you can keep in your mind: permutation is used when order matters. Okay, and combination, i will uh, I will tell you the formula and all for the combination. Okay, so combination I can use when order doesn't matter. Okay, basic, these two are the key difference in while using the permutation and combination. Okay, I will come to this point, do not worry. So the this keep just keep this difference in your mind. Okay, now let me tell you something about more permutation, right? I mean, there are some different criteria for permutation. Then I will move to the this concept. Okay, now so one more another concept in permutation is that suppose rearrangement of the letters. Okay, rearrangement of the letters. So what do you mean by rearrangement? Suppose I'm saying I have word, let's say data. Okay. In how many ways we can rearrange? That is the question. Okay. In how many ways we can rearrange? So what are the ways? Yeah, tell me any thought? First of
Sir,
all, if you see, okay. First of all, if you see, okay, forget about these data. Suppose these are four different. Let's say one is A prime. Then in how many ways you can rearrange these things by the formula which
24
you
ways.
sorry?
24, right?
No, why 20?
4 into
4 factorial.
Okay, you are talking about
Yes.
4 factor. Yes,
yeah, 4 factorial. Yeah.
correct. If this is the case, right? That is the 24 ways. But if you see the carefully, I have data, right? Just consider D as this is as A1 and this is the as A2, correct? For example, then if I want to rearrange that, I can write D, correct? A2 T A1. Yes or no?
yes, sir.
Yes, sir.
If I can write this another thing as TA1 DA2 or TA2 DA1, correct? But if you see carefully, so this one as this one as both are the same, correct? Yes or no?
Yes,
Correct.
Yes, sir.
Again, this one is the same, right? Something like that.
Yeah. Yeah.
Correct. So basically, what you can observe, so these two are the one, right? One thing. Okay. So what we are doing, there is a rearrangement of A again. So we can divide by 2 factorial or not.
Yes, sir.
Correct. Because anyway, see, these two are going to be same. Correct.
yes, sir.
Okay. So we got 4 factorial divided by 2 factorial. What is these two means? This is for repeating. I mean the number of times later are repeating. Correct.
Yes, sir.
Yes or no?
Yeah.
Correct.
Yes, sir.
And this is the number of letters,
Words.
right, in the word.
Yes, sir.
Correct. Now, so what we can we generalize the formula means if number of permutation of n objects, right? Correct. When p of them are repeating and rest are same. I mean rest are distinct. I mean one. I mean equal. They are repeating only one time. So it's basically n factorial divided by p factorial. Can I say or not? In the previous formula data, if you see, so 4 are different and divided by 2 are the same. We will get 12 ways, correct? If all are different, let's say DBTC, something like that, then it will be 4 factorial. Okay,
Yes, sir.
correct? Or you can divide by 1 factorial also, 1 factorial into 1 factorial into 1 factorial. Anyway, we'll get the 4 factorial. Is this clear?
Yes,
Yes,
sir.
sir.
Okay.
Yes,
Yes.
sir.
So, okay, what
Sir,
about, yes?
sir, can you just scroll up?
Mm-hmm.
Yeah, here, if no no letter is repeating, then
Mm-hmm.
we can take 4 factorial, right?
Mm-hmm. Yes.
No, that is same as NPN, right? If I'm not
Yes.
wrong.
Yeah, that's why we are done. Correct.
Okay, okay. So this is how we are getting n factorial.
Yeah.
Okay.
Okay. Yeah. So suppose there is another word, let's say statistics. Correct. So if you see, what are the total number of letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? N is
Yes,
equal
sir.
to 10. Correct.
Yes,
Okay.
sir.
So if you see, there are some different. I mean, some there are some more than one letters are repeating. So if you see S, how many times?
3 times.
And
Times.
T is
3
also
times.
repeating 3 times.
3 times.
I is also
3
repeating.
times.
Two
Two
times.
times.
2 times.
Correct. And that's all. correct?
Yes, sir.
So what will in how many ways you can rearrange? 10
10
factorial
factorial by
divided
3
by
factorial.
3 factorial,
3
3
factorial,
factorial,
3
2
factorial,
factorial.
2 factorial.
Yes or no? Okay.
Yes, sir.
You can also do for C one times, right? One factorial in case, and for A also.
Doesn't matter.
Okay. Then, so this is the something. Okay. Is this clear? Some rough idea is okay for you?
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir, it is clear.
Okay. Now, okay. Have you covered till clockwise, anti-clockwise?
Yes, sir.
Okay.
So I have not covered, sir, week 6.
Okay, no problem. Okay, so far the concepts are clear. Permutation, factorial, NPR, and repetition and non-repetition, rearrangement of the letter.
Yes, sir.
Okay. Now,
Yes, sir.
So,
yes.
can you please scroll up?
Yeah.
Sir, rearrange.
Yeah. Okay.
So here, DA1 and DA2. Sir,
Hmm.
here A1 and A2 is same or different?
It's the same. Actually, I took the different. Just I named as A1 and A2 so that we can get the idea. Anyway, suppose see, anyway there are two A, right?
Yes, sir.
So while you can, I can write this A at this place. I can write this A at this place, right?
Yes, sir.
So those two conditions I will count as a one, right? Because letters will be, I mean, word will be the same,
Yes, sir.
correct? That's I just wrote A1 and A2 because if you will say at the end I will get data itself, correct?
Yes, sir.
Okay, clear?
Yes, sir.
Okay.
And so only repeating elements we take in the denominator, na?
Yeah, that's why. See, you okay? You see why I divided by 2 factorial. If I have two letters, right? Two letters at the same, I will get the two words at the same, right?
Yes, sir.
If I will have the three letters in the repeaters, then I have to divide with 3 factorial.
Okay, sir.
Got
Got
it?
it.
Yeah.
And sir, if there is no repeating letter, then?
Okay. If there is no repeat, I think, okay, what about this thing?
Yes, sir. Yes, sir. Got it.
Suppose you have got any some random word DBTC. I can, first of all, I can rearrange in 4 factorial ways, right? Okay.
Yes,
Suppose
sir.
all the words are repeating one time. So can I divide 1 factorial, 1 factorial, 1 factorial, 1 factorial?
No.
Yes, I can. See, what I'm doing, I'm dividing by the number of times which, I mean, the number of times they are repeating.
Yes,
See,
sir.
all letters are repeating only one time. So I can divide 1 factorial, right?
Yes, sir.
Are you getting my point? See, in
Yes,
this
sir.
case, see, DBTC means what? I can write lots of I mean there are total 4. Okay. So at the first place, in how many ways you can arrange? I can take any of the 4, then any of the 3, then any of the 2, any of the 1, right? I can take 4 factorial. Since no letters are repeating, that means it will be basically 4 factorial. Okay. If you apply this formula, if you see here, A is repeating 2 times, correct?
Yes, sir.
Into what I can do, D is repeating 1 times, I can multiply with 1 factorial. Similarly, T is repeating 1 times, I can multiply with 1 factorial. Anyway, answer will not equal. Just to give to you idea, if a letter is repeating some 2 times, 3 times, so we have to divide by that number of factors. Okay?
Yes, sir.
Right?
Sir,
Yes?
sir, can you just scroll up?
Mm-hmm.
Yeah, here.
Sir, I basically joined right now.
Yeah, go ahead, go ahead.
So could you
Sir,
please read the first part? Like, is this about dictionary?
I think you joined the, it's a statistics session.
Yeah, the
Yes, sir.
repetition of words.
Okay. Okay, you are talking about dictionary word.
Yeah.
Okay. I thought I went into Python. Okay, no problem. Okay, so I will go to that one. Okay, so yeah, someone was asking this.
yeah, sir, even this formula is derived from NP, right? NP, this becomes NP n minus r factorial, uh, which is getting out to be n factorial by r factorial, right?
n factorial.
Even this is a permutation.
See, that is something I'm going to arrange r objects out of n, right?
Yeah. If say for example, any one letter is repeating for
Hmm.
r times, then it
Then
becomes
we
n factorial by n. Sorry.
see
Um,
that r
np
times
n
is
minus.
see that r times is we have to divide the suppose a letter is repeating r times, then you will see this is something total, right? And divide by number of times they are repeating.
So it is
Factorial of
basically
this.
telling about NPR, NCR.
Yeah, yeah,
Okay.
sir. If we
Hmm.
consider this as uh, permutation,
Hmm.
then it will become n factorial by n minus r factorial.
No, no, R factorial will 10 minus R.
N, um,
That's
so
NPR and
this
CR.
becomes
See.
okay. Just a moment. Confused. So
See.
this becomes like
Hmm.
np n minus r factorial, right?
np n minus r.
No, it's NPR.
Yeah, yeah. If we
Hmm?
yeah,
Okay.
np n minus r. If we uh, derive this from the formula, we'll get this n factorial by
Okay.
r factorial.
See, anyway, both are the same. See, you are just doing the manipulation in the formula. Doesn't matter. So, thing
Yeah,
is,
yeah.
need to
So if
understand.
we
Hmm.
like for different cases, we'll remember this formula. So it will become sometimes difficult.
See. That's why I'm saying
Like
don't. Don't memorize the
it takes
formula
more
only.
practice. So
Listen to
from
me.
an
What I'm saying.
NPR formula itself, we can
I think should I
understand
speak?
everything easily.
Should I speak?
Yeah.
Okay. So what I'm saying, don't memorize the formula at all, right? So try to understand the concept itself. You will get the answer. See, if you have any word, right? Suppose I'm saying any word. Let's say, someone asks me dictionary, right? Suppose I have dictionary word. Okay, correct. First of all, see suppose you want to rearrange the letter. In how many ways you can rearrange? How many letters we have? How many places we have? 1, 2, 3, 4, 5,
10.
6, 7, 8, 9, 10. I can rearrange 10 factor, right? But if you are going to rearrange, so if you see there are I is repeating, correct? I think only I is
Yes,
repeating,
sir.
correct? So if you see, if you consider, let's say this is I1 and I2, for example, if you will replace I2, I1, so these two cases will be same, right?
Yes, sir.
Correct? So we have to divide by 2 factorial. That's all. Because you are going to consider both letters as the same. That's all. Okay. So
Yes,
that
sir.
formula has been generalized. You have n letters. You can do n factorial. If p of them are repeating, let's say p1 of them are repeating, divide by p1 factorial. Suppose suppose for example, y is also repeating. For example, then you will multiply with p2 factorial. Suppose this will be 2 factorial, something like that. Okay. Okay. This idea is okay. Fine.
Yes, sir.
Okay. Yeah. So, okay, let me start with the one more thing in permutation combination. Sorry, in permutation, that concept called clockwise and anti-clockwise. After that, we'll move to the combination concept and we'll give you some. We'll see the difference between permutation and combination. Okay. Now, there is one more concept called circular permutation. So in circular permutation, there is two things. If you are doing circular permutation, then there will be two cases. First case will be like when, so there will be clockwise arrangement, right? So first will be, we are going to consider clockwise and anti-clockwise are different. Arrangement of clockwise and anti-clockwise are different. Then arrangement as clockwise and anti-clockwise are same. Okay. So we'll see the formula for that. Okay. So what is the meaning of clockwise and anti-clockwise are same and different? So first we'll see this case when clockwise and anti-clockwise are same. Okay, fine. So what is the meaning of this case? Clockwise, anti-clockwise are same. Sorry. Let's discuss first different. Then we'll see the same case. Okay. Now, tell me. Suppose if we have some four people A, B, and C. Sorry, A, B, C, and D. If I want to arrange in a linear manner, in how many ways I can arrange these people in a
24.
row? In a basically 4 factorial, right? For
Yes,
the
sir.
first
Yes,
Four
sir.
place, I
factorial.
can take any of the first 4 people, then 3, then 2, then 1. That is nothing but 4 factorial. Yes or no?
Yes.
Okay. What
Yes,
are
sir.
these? If you see, what are these arrangements? These arrangements are nothing but will be A, B, C, D. Correct. Then
A,
B,
C, B,
C.
D.
Yeah, B, C, D, A or C, D, A, B and
DCBA.
D, A, B, C. Okay. Something. I mean, basically. I mean, see, this is something we can find something like that. Yes or no? Okay,
Yes, sir.
ABCD,
24.
Yes, sir.
24 cases will get right. So thing is that what about if I want to arrange these people in circular manner. So if you see, I want to arrange in a circular manner. Suppose A, B, C, D. Okay, okay. Basically, this again. Then I can arrange this as a B, C, D, A, right? Then
With C and with C. With C and with D.
okay. Uh,
B, D, A, B.
okay. Let me write on the second page first. Okay. First of all, tell me. Okay. Let me write the all the possible cases. Okay. So I can write A, B, C, D. Right. Then
Then with B, B,
A.
C, D,
Yeah.
A.
With C also I can write right. A,
Yes,
C,
sir. Obviously.
D, B. Right. Correct. Then A, D, B, C. Correct. Then I can write A, D, C, B. Okay. Then I can write A, B, D, C. Then I can write A, C, B, D. Right? Basically, these are the total cases, total 6 cases. If I'm going to arrange the 4 people on a circular table or in a circular manner, so this is the total 6 cases. Okay. How will I get the 6 cases and what is the formula? So there is one formula says, I mean, I will tell you from where we got actually. So the number of ways, okay, okay, before going to okay, tell me if you want to arrange the people on a circular manner, so all these orders are same, sorry, different, correct? If you
Yes,
see,
sir.
if I'm writing A, B, C, and D, correct? Okay, so first of all, in how many ways I can arrange these people?
4 factorial ways.
4 factorial ways, right? If it's in linear, suppose, see, anyway, A is here. For example, suppose A is sitting here from A, B, C, D. I can say, right? If you start from here, I will get the same arrangement.
Yes, sir.
Are you getting? So basically, we'll get this A, B, C, D. Okay. Then before that, I will get the A, B, C, D. Let me use some other color also. Let me use green. Suppose A is sitting here, then again I will get the same arrangement.
Yes, sir.
Yes,
Correct?
sir.
Because it's a circular manner, right? There is not a row case. Correct? Let me use the brown color. Suppose A is sitting here. Suppose A has been seated here, then A, B, C, D. Again, I will get the same pattern. Correct?
Yes, sir.
See, if you are here, you will see the same order, right? A, B, C, D. If you are here at the red one, then again you will see the same order A, B, C, D. If you are here, then you will see the same order A, B, C, and D. If you are here, then you will see the same order A, B, C, and D. Yes or no?
Yes, sir.
So if you see,
Yes,
these
sir.
four things are going to give you the same order.
Yes, sir.
So
Yes,
can
sir.
I, to get the different, I have to can I divide by 4? Yes or no?
Yes, sir.
Why
Yes, sir.
4?
Yes, sir.
Because see, these four is going to give you the same value. I mean, same order.
Yes.
Okay.
Yes, sir. Yes,
So
sir.
these four factors for different, and this four is I'm dividing because I'm going to give I'm going to get these four as a same single one. Correct? Okay.
Yes, sir.
So I have to divide by the 4. Yes or no? So
So
what
then
is
will
this?
the result be different for linear and circular?
Yeah, yes, so that's why we are studying, right? So this is for the linear. See, anyway, in linear, all the things will be different, correct? In
Yes, sir.
circular, if you are here, then you will see the same arrangement, correct?
Yeah,
Correct?
Yes.
exactly.
So what is this? This is something I can write 4 into 3 factorial divided by 4. That is 3 factorial.
Yes, sir.
Yes.
So basically, if
6.
you see, what is 3 factorial is nothing but 6, right?
Yes, sir.
So we got these 6 different arrangement. These are the 6 different arrangement. Okay. So if you see, I had to arrange 4 people on a circular manner. Then I got number of ways. In how many ways I can arrange? 3 factorial ways, right? Correct.
Yes, sir.
Yes, sir. N
When
minus 1 factorial.
when clockwise and anti-clockwise are different. If you see here, clockwise and anti-clockwise are different. So that means the number of ways and distinct, right, objects can be arranged in a circular in a circle or when clockwise and anti-clockwise are different. Okay. Is nothing but n minus 1 factorial. Is this clear? Some rough idea is okay.
Yes, sir. Clear.
Okay. So
Sir,
let
means the denominator is nothing but the number of letters in the word, right?
denominator is nothing. Can you repeat where you are asking?
Sir, the denominator in 4 into 3 factorial by 4, that
Hmm.
the denominator 4 is the number of letters in the word, right?
It's not about letters. See, it's not. It's about this. See, these 4 arrangement. These is the same, right? I can consider as a one arrangement.
Yes.
Yes or no? That's why we are dividing. It's not about letter. It's about
Yes, sir.
yeah. You can say it's letter or people. So these A, B, C, D, C, and D are 4 different people. Okay.
So the denominator is number
So,
of
so,
repetitions.
Yeah.
Yeah.
Number of times.
sir,
See,
means
Repetition.
if number of letters are 5, let's say, then the same circular pattern will be followed 5 times.
yeah, it's any number. See, that's why I have generalized here. Okay. For n, it will be n minus 1 factorial. For example, if you are talking about 5, okay. So let's say some 5 people are there. Okay. Let's say A,
Okay.
B, C, D, E. Okay. Okay. So of course, suppose these are the 5 people. If you want to arrange in
Yeah.
linear manner, in how many ways you can arrange? In 5 factorial
5
ways.
5
factorial.
factorial
Correct.
ways.
So suppose these are the
Yes.
5 people. So
Yes.
these are okay. Okay. Suppose you are here. Then you will get the A, B, C, D, E as a one arrangement. Okay.
Yes, sir.
Yes.
For example, see, there is a possibility A can sit here, then B can sit here, C can sit here, D can sit here, E can sit here. If you are here, again you will get the same possibility.
Yes.
Yes or no? Similarly, if you are here and A has seated here, then A, B, C, D, E, again you will get the same possibility, right?
Yes.
Similarly, you will get the same time, 5 times. Okay.
Yes. Yes.
So these 5
Got it.
factorial are the linear arrangement, and we are dividing by 5 because we are interested to know the different ways, total number of different ways. So basically this
Yes.
5 factorial 5, it will give you 5 into 4 factorial divided by 5. It's a 4 factorial.
Which is 4 factorial.
If I have
Okay, sir.
n
Got it.
objects, I want to arrange in circular manner when clockwise and anti-clockwise are different, then I will be having n minus 1 factorial ways. So it's for circular. If it's a linear, I will simply say n factorial. Doesn't. Okay.
Okay,
Is this
sir.
clear?
Yes, sir. Yes.
Fine.
Sir, why n minus 1?
What is this? For 5, what I got? I got 4 factorial, right?
Yeah.
So if 5, so if suppose I can generalize it. So I can generalize if I have n, then I will be having n minus 1 factorial ways or not. See.
Okay.
So if
Okay.
two
Okay.
letters are
Okay,
same,
sir, got
then
it.
It's not about letters. I'm talking about some 5 people which we have to arrange on a circular manner. This A, B, C, D and E are 5 different person. Okay.
okay, sir. Yes,
Yeah.
sir.
Okay. So this actually
The
this,
repetitions don't affect it, right?
yeah. See how you can say 2 people are same. I mean something anyway, or arrangement will be different, right? Okay.
Repetitions will only affect it.
Yeah,
It's
that
not
is
the
a
number of
different
letters.
case, repetition and
It can
all.
be about the numbers also. It is not about the people. If we take the same numbers, arranging the same numbers in circular order like that, we can
So
do.
here
Then
let's try to understand this formula where it came actually. Okay, so I'm trying to explain where if you have n object or n people, if you want to arrange on them on a circular manner, suppose there is a 5 people, they want to do a meeting on a round table or circular table or something like that, then in how many ways you can arrange those 5 people? So you can arrange in 4 factorial ways. Okay. Is this clear? Some rough idea is okay
yes,
for
sir,
everyone?
yes, sir.
Fine.
Yes, sir. Yes, sir.
Okay.
Yes, sir, clear.
So
Yes, sir.
this n minus 1 factorial ways will be when clockwise and anti-clockwise are different.
Different.
Okay. Now what is we'll see the case here when clockwise and anti-clockwise are same. Okay. Means we are doing the arrangement such that clockwise and see if you will see the arrangement clockwise or anti-clockwise, both will look like the same. For example, you can see the necklace. If you see the necklace of same beads, something like that. So if you see actually clockwise and anti-clockwise are same, means mirror image is same. So if you see the same necklace in mirror image, so it will look like same in mirror image also.
Yes,
Yes,
sir.
sir.
Yes, sir. Yes.
So
Yes, sir.
basically, so what is the formula in such kind of cases? Okay. So let me I will let me just draw some graph. Then you will be having idea what is the meaning of clockwise and anti-clockwise are same. Okay. Suppose I have A, B, C, and D. Okay.
Yes, sir.
Then I will be having suppose A, C, D, B. Then for example, I have A, D, B, C. Then A, D, C, B. Okay. Then A, B, D, C. Then A, C, D, and B. So what do you mean by clockwise and anti-clockwise are same? If you see this formula, I'm sorry, this clockwise arrangement. So what I got A, B,
A,
C,
B,
and
C,
D.
D.
Correct? Right? In the same case, if you see anti-clockwise,
A,
I
B,
will get
C,
A,
D.
B, C, D. That means okay. So this is the meaning of clockwise and anti-clockwise are same. So this is the these two cases will be same. Yes or no?
Yes, sir.
Yes, sir.
Here, if you
Yes,
see, I
sir.
got AC, DB, right? Correct? If you see here,
ACDD.
anti-clockwise, again you will get AC, DB. So
Yes, sir.
can I say these two arrangement are same?
Yes, sir.
Clockwise, anti-clockwise. What about AD, BC? And here, if you see
Same.
anti-clockwise, AD, BC. So
Yes,
these
sir.
two are
They
same.
are
Okay?
also same.
So basically, if you see what is the two different ways, I mean, when clockwise and anti-clockwise are same. See, these two are the same anyway. So what is the total ways? Total different way. See,
n minus 1 factorial by 2.
N minus 1.
no, it's not about n minus 1. See, if you see, not one, see, when I had n people on or something, I had to arrange anti-clockwise on a circular manner. When clockwise and anti-clockwise are the different, then I got n minus 1 factor, right?
Yes, sir.
Yeah.
Correct? For 4, I
Yes,
got
sir.
3 factorial, that is 6. Correct?
Yes.
But when clockwise and anti-clockwise are same, that means these two cases are same, right?
Yes, sir.
That means I have total three cases when clockwise and anti-clockwise
Yeah.
are same. Correct?
4
Yes.
factorial by 3 factorial.
Not 3 factorial, only 2 divided by 2. See, cases will be half.
N,
See,
yes,
these
sir.
two is 1, these two is 1, these two 1. Okay. So basically, we got 3 factorial by 2, right? It will be
Yes, sir.
total 3 ways, right? So
That
this is the
formula
I
is
won't
N.
understand to why so.
because these two cases are same. If you are considering, if you see the clockwise and anti-clockwise arrangement are same. See, in this case, if you go clockwise, you will get the arrangement ABCD. If you go anti-clockwise, again you will get ABCD.
Yes,
Correct?
sir.
Same for here, ACDB. If you go anti-clockwise, you will get ACDB. Right? In this case, if you go, you will get ADBC and anti-clockwise ADBC. Right? So if you see arrangement are same, right? If I'm going clockwise and anti-clockwise, both
So
are the
we'll get
same.
them 3 times, right? So we can consider as 3
Yes,
factorial.
sir.
So basically, so we have to divide the by 2.
2.
Okay. So this is
So
the something.
then we should divide by 3 now.
See, it's a total 6 cases when clockwise and anti-clockwise are different. Now, how many unique are there you have? 3,
Yes, sir.
right? So 6 by 3 is 2, or you have to do 6 by 2?
6 by
Yes,
3.
sir.
6 by 3 or 6 by 2?
6 by
6
2,
by
sir.
2.
6 by
6 by
2,
2.
right? It's a half, right? Okay.
Sir,
So it's
then formula is N minus 1 factorial upon 2 again.
2, yes. Okay. So the same thing, if you have n distinct objects, if you want to arrange in a circular manner, okay, when clockwise and anti-clockwise are same, then I can arrange in total n minus 1 factorial divided by 2
2.
ways. If clockwise and anti-clockwise are different, then
N minus 1 factorial.
it was n minus
Minus
1 factorial.
1 factorial.
Okay. Actually, this we got from the linear n factorial divided by n, and this is we got from when clockwise and anti-clockwise were different. Okay. Is this clear? Some
Yes, sir. Yes,
Yes,
sir.
sir.
fine, right?
Yes,
So
sir.
you, okay, so you
Yes,
got
sir,
the
got it.
idea from where we got the formula itself, right? It's not like some formula came randomly, right? Okay, fine.
Yes, sir.
Okay. Then now let's move to the concepts of permutation and combination. Now we will see when to use permutation, when to use combination, what is the difference. Okay. So these are the major problem. I mean, some people are not able to differentiate between permutation and combination. Okay. Now, so let me tell you what is the meaning of permutation. Okay, so I told you in, I think it's good if you mute yourself whenever you don't have any doubt, because some background noise is coming. Okay. So permutation and combination, there is difference. Permutation we are
Sir, I
using.
have a query.
Yes.
So if there are 5 people, but there are 4 seating arrangement, and how will we arrange them in the circular order? Can you solve this?
I will come. I will come. For that, combination is required. First of all, you have to choose 4
Okay.
people out of 5. Then you can arrange.
Okay, sure.
Okay. Yeah. So basically, what is the combination first? Okay, permutation, you know. So the key difference between permutation and combination is permutation I will be using when order matters, and combination when order doesn't matter. For example, I'm saying I have three people A, B, and C. Okay, just listen me carefully. If I want to just uh, suppose these are the three people in a room. I want to choose or I want to select, okay, two people. Okay, then in how many ways I can do? First of all, that is my question. Okay, first of all, if I want to choose two people, I can choose A, B, correct?
Yes, sir.
I can choose B, C, I can choose C and
A,
A.
C, A.
Okay, if I am choosing B and A, these two are same. Anyway, see, I have selected two people A and B, right? Because I'm
Yes.
interested only selecting or choosing two people out of three, right? Yes or no?
Yes, sir,
Yes,
they
sir.
are the same.
Correct. So if suppose I have to see anyway, if I selected C first, then B, anyway both these two are same. Or I selected A first, then C, anyway both are these two are same, right?
Yes,
Yes,
sir.
sir.
So here order doesn't matter, right? Here order doesn't matter. If you see, order doesn't matter means order is not matter whether I selected A first, B second, B first, A second, something like that. B first, C second, C first, B second, something like that. Okay. But I will be having total how many combinations? Three, right? Okay. So this is the something this three we got from where. So there is one formula called if I want to choose R objects, okay, out of N, then I can choose in NCR ways, which is denoted as N factorial. I mean, formula is N factorial divided by R factorial into N minus
Yeah,
R
minus
factorial.
R
Okay,
factorial.
this is the formula of combination. We are not going to in the derivation part. I will tell you for this. Okay, here I had three people, correct? And I wanted to choose two people. In how many ways I can select? So it's a 3 factorial, right?
Upon
Divided
2
by R is
factorial
2 factorial. 3 minus 1,
minus 1 factor.
sorry,
No,
2.
2.
3 minus 2.
3.
It will be 3 into 2 factorial. I can write in the numerator part. It will be 2 factorial into 1 factorial. 1 is 1, 2 will get cancelled. I will get 3. So these
3.
3 are the ways, correct? So here you can see order doesn't matter. Okay.
Yes,
Are you
sir.
okay? Are you getting the point? Okay. So what I mean by the order matters. Suppose I'm saying I have three people A, B, and C. Okay, and there is two positions of let's say president and vice president. Okay, for example, and I have to choose two people in such a way I have to make president and vice president. Then in how many ways you can do? Suppose I have selected A and B, right? Okay. Then if A is the president and B is the vice president, or B is the president, A is the vice president, then these two order are different or not?
Yes, sir, different.
Correct? Suppose so. Okay. First of all, what is the total combination? A and B, then A and C. So correct.
3
Then
combination.
B and A,
Yes,
B
sir.
and C, C and A, C and B, right? I mean, these are the
Yes, sir.
total. Okay, so just try to understand the difference. Suppose there is two positions of president and vice president, okay? If A is the president, B is the vice president. Here, if you see, B is the president, A is the vice president. So this and this are the different because
Yes,
here
sir, they are
order
different.
matters, right?
Yes, order.
Here order matters, yes or no? See,
Yes, sir.
AB is the not same as the BA because I'm talking about some position, some order, right? Some ranking. Yes or no? If you
Yes,
see
Yes,
sir.
sir.
similarly, A and C, if A is the president, C is the vice president, and here C is the president, A is the vice president, these two again are not same.
Yes, sir.
Same for B and C and B. Yes or no?
Not sir.
Not same, right? So if you see
Yes, sir.
what is the total case, we got 6 ways, right? Okay. So
Yes, sir.
this came okay. So in this case, permutation is useful because I'm talking about order arrangement. That means if you see, I had 3 people and I had to choose two people for the order position. So I got okay. What is the formula for factorial? So permutation is a 3
3
factorial.
factorial by 2
3
factorial.
minus
Yeah.
2 factorial. So we got 3 factorial divided by 1 factorial. So it's nothing but 3 into 2 into 1, which is 6 ways. So if you see, we got the 6 ways. Yes or no?
Yes.
So are you able to differentiate here? Orders matters, right? There is some position, something order is there. While in the previous case, the total combination are 6, but in the combination we are not worrying about order, so there will be total 3 ways. Yes or no?
Yes, sir.
Okay. So if you see the formula, one concept is there. If you see NCR is n factorial divided by r factorial into n minus r factorial, right?
Yes, sir.
So that means, can I write NCR into r factorial equal to n factorial divided by n minus r factorial?
Yes, sir.
So what is this? NCR into r factorial. Right hand side is nothing but NPR.
The NPR. Yes, sir.
So if you try to understand the formula, what is this? NPR is nothing but, first I'm choosing R people out of n, then I'm arranging those R people in R factorial ways.
Yes, sir.
Correct? So if you
Yes,
see
sir,
this,
absolutely.
if you see the previous formula itself, so I had to arrange these two people on a vice president manner. So what I can do, suppose, okay, so there are another approach is, I can select two people out of 3 in 3C2 way, right? Now, after that, I can, in how many ways arrange 2 people in 2 places, position? 2 factorial ways, right?
Yes, sir.
Okay. So actually, permutation and there is this is the relation from permutation and combination. Okay, is this clear? Some okay, rough idea is okay. What is the
Yes, sir.
difference between permutation and combination?
Yes, sir.
Yes, sir.
Yes or no? It's clear?
Yes.
Okay. So
Yes,
when
yes,
to
sir.
use permutation? Okay, so don't get confusion, right? Sometimes we are just directly using NCR, NPR without thinking the logic behind it. Just think whether order matters or not. If order matters, I will use permutation. If order doesn't matter, I will go for the combination. Okay.
Yes, sir.
Okay. There is another concept, drawing lines on a circle. Okay, that from there you will get some clarification also. That is another formula also. So what is that? Drawing lines on a circle, actually. So basically what it means, suppose, okay, let's talk about with the two point. Okay, suppose this is the one circle. Okay, if there is 2 points, let's say a point A, another point is B. Okay, in how many ways I can draw a line?
One way through these 2 points.
One way.
One way or two way?
One
Two
way.
ways, sir.
Two ways, two ways.
Two.
From
Okay,
A to B,
okay,
from B to
suppose,
A.
Two.
okay,
Sir, if
I'm
Yes, sir.
direction
A to B, B to
matters,
A.
2
Direction.
ways. If direction doesn't matter, if it is a ray, then only
Mhm.
one way.
Yeah.
Okay, so if direction, I'm saying direction doesn't matter.
Two
Only
ways,
one.
sir.
One
Only
way.
one. One.
Hmm? Yeah, just think. Whether one or two. I'm saying
Sir,
direction not matter.
should it pass through
One.
these 2 points A and B?
See, that's why I'm saying on a circle, we have 2 points. I'm saying direction is not matter. In how many ways you can draw a line or a line segment, something like
Two
that.
ways.
One.
Direction
One way.
not matter. See, if direction doesn't matter, if I'm going to A to B or B to A, I will get only one line segment. That is AB, right?
Yes,
Yes.
sir.
Correct?
Yes, sir.
If direction doesn't matter, if I'm connecting A to B or B to A, so what I can use here, if you see, I have 2 points, right?
Yes,
And
sir.
I have to
Yes,
choose
sir.
2 points to make a line, right?
Yes, sir.
That is one way. Okay, here direction doesn't matter, here order doesn't matter, right? It's something about direction or order. Okay, let's talk about 3 points. If you have 3 points, suppose I have 3 points here, A, and this is B, for example, this is the C. Okay, so in how many we can do? First of all, line segment will be, first of all, I can do A, B, right? B, C, and C and A. if I will go vice versa, I will get the same line segment. I will get anyway, I will get A, B, B, C, and C, right? Anyway, if I'm connecting B and A first, or C and B first, then A and C, anyway, both are the same.
Yes, sir.
Yes,
So
sir.
here direction doesn't matter. We are not about worrying about order. So okay, so there is formula. I have 3 point, right? And I have to connect 2 point to get a line, right? That is something I can do in how many ways?
3
3
times.
factorial, 2 factorial, 1 factorial. I will get 3 ways.
3 times.
Yes or no?
Yes, sir.
Yes, sir.
Is this clear, right? Are you getting? So
Yes, sir.
similarly, if you have n
Can you
points,
explain once again this?
okay. So if you have 2 points, suppose there is a 2 points on a line. In how many ways you can draw a line by adding? I mean, considering these 2 points without direction. There is no need to worry about direction.
The one way.
One way, right? So either you are connecting A, B first or B, A first, order is not mattering, right? There is only one way, right? So if you see the formula, I basically what we have to do, I have 2 points and I have to choose 2 points out of, two to connect a line. That is one way, right? So here if you see, I'm using the combination because direction doesn't matter. Okay. Same.
Okay, sir.
If you have 3 points, if you have 3 point, right? So to make a line, right, to make a line points, or I want to connect these points, right, line segment, in how many ways I can do? If I'm connecting A and B first, or B and A, anyway I'm going to get a one line segment AB.
Yes, sir.
I'm going to B and C, or C and B. If I'm not worrying about direction, okay, then I'm going to get the same line segment. Same. C or A, C to A or A to C, right? Correct. So there are
Yes, sir.
total 3 ways, right? Correct.
Yes,
Yes or
sir.
no? So if
Yes,
you
sir.
see what we have to do, I have total 3 points, and I have to choose any two, right? Here I'm considering I have to select, I have to choose any two. I'm not worrying about order. I have to choose any two to make a line segment. So for that, I will use the combination which is 3C2, 3 factorial divided by 2 factorial into 1 factorial. That is total 3, which is the
Sir, here it is not clear. Why 3C2? How?
because you are total 3 dot, right?
Haha, yes.
To connect a line segment, to make a line segment, how many points you need to choose? Two.
Connect. Two.
Right?
Okay.
See, I have n people. I have suppose 4 people. I want to choose 3 people without considering in order. I can choose in 4C3 ways, right?
Okay, got it.
Got it?
Uh-huh.
So the general formula is if you have n points, right? And the number of line segment, okay, you will tell me the formula. The number of line segment, okay, that can be drawn, okay, connecting the points. In how many ways I can do? Tell me the general formula by
NC n minus 1.
NC n minus 1. Just think, I'm asking what to, we have to make a line segment. For 2, it was 2C2. For 3, it is 3C2.
Yeah, NC n minus 1.
Okay, for 2 points, I have written 2C1.
No.
Yeah, just think.
NC2.
NC2, right? To make a line segment, you need any two points. That's all. Yes or no?
Yes, sir. Yes, sir.
Is this clear?
Yes, sir.
Okay. No, let's change the scenario. If I'm worrying about the order, okay. If I'm worrying about the order, that means when to use. Okay, basically, suppose then you will tell me basically for example, okay. The same case, suppose I'm worrying about drawing a line, okay, on circle, okay, in a circle basically. So when I'm considering about the order, okay, when order is important, when order is important, okay. Let's see. If you have two things, right, 2 dot, A and B. I'm mentioned order is important. That means if I'm going A to B, for example, then uh sorry, B to A and A to B, these two order are different, right? So there
Yes,
are
sir.
total how many ways?
Two ways.
Two ways, right?
Yeah.
In the previous order was not matter, right? If you have, let's say, 3 points, something like that, okay? Suppose A, B is here, C is there. If I'm going A to B or B to A, right? First, let's say this one, A to B, B to C, then C to A. This is the different A, B, B, C, and C, A, right? Or else if you are going B to A, then A to C, then C to B, again it's different, right? Yes or no? See, direction
Yes, sir.
matters.
Yeah.
Yeah, are you getting my point here? So what is the
Yes.
total number of ways here?
6.
6 ways, right? So if you see if direction matters, so can I say this is I have 2 point, then I can use 2p2 or not? If you apply the formula npr as n factorial divided by n minus r factorial, then it will be 2 factorial divided by 2 minus 2, which is 0 factorial, which is nothing but 2 ways, right? We got the 2 ways. We can get the by the using formula here. I'm using permutation because their order is matter, direction is matters, right? Yes or no?
Yes, sir.
Correct?
Yes,
If
sir.
you see here, orders matter. I have 3 points. I have to do for 2 points, right? Then I can do in how many ways? 3p2 way. Yeah, because order is matter. That means 3 factorial divided by 3 minus 2 factorial, which is 3 into 2 into 1, again 1. So I got 6 ways, right? Which is 6 ways. These are the total 6 different ways because order matters. While in the previous case, order doesn't matter, then I simply took C2, 3C2, which was the 3 ways. Is this clear when to use permutation or combination?
Yes, sir. Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Right? Okay. For example, let me take another example. Suppose I'm saying, let's say in today's session, there are some 25 people. Okay. Let's say I have 25 students in today's class. Okay. For example, let me write here from there itself 25 students. If I want to choose two people, two students out of this 25, just for any something like I have to choose two people. In how many ways I can choose?
25C2.
25C2? Because order doesn't matter. Whether I'm choosing A1 first, A2 second, A2 first, A1 second. Anyway, I selected these two people, right? Yes or no?
Yeah.
Yeah. These are the total ways, right? For example, I want to choose two people, right? To make one as a president or as a, let's say, uh, captain and vice captain. Okay. Then in how many ways I can do? First of all, let's go with this formula also. So first of all, I want to choose two people. In how many ways I can do? 25C2. Now I want to arrange these two people. See, here I have selected. These two people have selected, right?
Yeah.
Correct? Now I want to make these two people as a captain and vice captain. In how many ways I can arrange the people?
2 factorial.
Two
2
factor, right?
factorial.
Yes. Yeah, 2
If you
ways.
see here, this is nothing but 25P2.
Yes, sir.
Okay.
Yes, sir.
So if you observe carefully, so this permutation formula is already involved the combination. Okay, because in combination we are not worrying about the order, while in the permutation we are worrying about the order. Is that clear?
Yeah.
Clear for
Sir.
all?
Yeah, yes, sir.
Yes, sir.
Okay. So these were the main topics from week 6. Okay. So let me take some activity question. Hopefully you'll get some rough idea. Okay. Okay? Can you raise your hand? How many of you covered the lectures video at least? How many lectures are there? Some 4. At least 2. Just raise your hand. I will be having some idea. Accordingly, we can. Okay, 1 people. At least 2. You can raise your hand. 2.
Sir, in quiz, if we lose a question of 4 marks, how many marks are we losing?
4 marks. So question paper was, I think, 40 out of 40, right?
Yes, sir.
So just
sir.
multiplied by 2.5. Okay, only one people have watched at least 2 lectures. I think two are raised hand.
Pardon, sir?
Okay, so I'm asking how many of you watched the at least 2 lecture video from week 6?
From week 6, no, sir.
No, you haven't started, right?
Yes, sir. Week 5 I have completed.
Week 5 anyway, only 2 lectures video. Okay, no problem. Okay, so okay, everyone got the concept so far, right?
Yes, sir. Yes, sir.
Okay, so
Yes, sir.
do you have pen and paper right now?
Yes, sir.
Okay, great. So just see the first question and without checking the answer, clicking on the answer with your honesty, just do it and we'll discuss the answer in 2 minutes. Okay, after 2 to 3 minutes. Okay, so because I'm asking the question because we'll see whether you got the concept or not. Okay, so just do the first and second question. Okay, these two questions. Okay, don't think like you will see you will give tell me the answer directly by checking the answer here. You can tell me, but it's good to do without I mean with your honesty. Okay, like whether you got the concept or not. Okay, so you have now some 2 to 4 minutes. Just do it and we'll discuss. I wanted to discuss because we will be having some idea whether we will do. Okay. Okay, so are you able to solve it?
Yes, sir.
Okay. What is the correct
Yes,
answer?
sir.
So
3 power
I got
6.
15 and the third
Okay.
option is correct in second.
3
Third
power
option
6.
is
second
correct. Okay.
option,
Okay, and what about question number 1?
15 I
64.
got.
64.
729.
Okay, let's
15.
see.
3
Sir,
power 6.
15 I got. 15.
15.
For question number 1.
Yes, sir.
Okay. So question says, in how many ways can a test paper of 6 questions be attempted? Each question of being true or false. Okay, how did you approach? You got 15.
62 ways.
Okay, okay. Why did you think it's a 62 ways?
Because in every question there are two options, true or
Hmm.
false.
Hmm.
So
So are you choosing that any two or
anyone.
just think it should be 62, 62. See in this kind of scenario, right? So just think little bit carefully. Okay, so just think like this. You have 6 questions, right?
Yes,
You can write 1 question, 2 question, 3 question, 4 question, 5 question, and 6 question, right?
Yes, sir.
Yes, sir.
Each question is true or false,
False.
correct? So in how many ways you can attempt this question?
Two ways.
Actually, it's
One,
asking about
true or
attempting a
false.
attempting a question paper, right? So in
Yes.
attempting, see, it's possible. I have selected true. I selected false. I did not attempt this question at all. So basically, I will be having total 3 ways for this for question 1 or not.
Yes.
See,
Yes.
for example, okay, all of you have given the qualifier, right? Suppose there is a
Yes.
question which is MCQ, right? I'm asking whether you attempted the qualifier paper or not. So there is possibility you selected any option from that question paper, or it's possible you did not select any option from that question paper, right? For that question,
Yes.
correct? Same for question number 2, you will be having 3 ways, right? You can select true, you can select false, or you can, you skip that question. Yes or no?
Yes, sir.
Then 3 ways
Yes,
for
sir.
this, 3 ways for question number 4, 3 ways for question number 5, then 3 ways for question number 6. Yes or no? So we have to consider all 6 questions. So it's and 3 ways for first question, and for second, and for third, and for fourth, and for fifth, and for sixth. So it's total 3 ways for 6 ways. I think this is the something 729. Okay, is this clear?
Yes, sir.
Okay. So question number 2, if you see,
Yes, sir.
a professor is creating exam of 11 questions from a test bank of 15 questions. In how many ways can he select and arrange the questions? Okay.
Option second.
Option second, someone told option number 3 also. Let's see which one is the correct. Okay. So, okay, so suppose if you see question, okay, who told option number C?
Me, sir.
Kalyani, right?
Kalyan.
So
Yes, sir.
I think, see, you are right, but when, if I'm just asking, the teacher had selected 11 questions, okay, but if you see there is one letter, he select and then arrange. See, if you're doing the arrangement of the question, that, see, suppose I have arranged the question paper, okay. For you, I gave question 1, question 2 up to question 11. This one arrangement is another. Suppose for some people, he got question number 2 as first, question number 3 as second, then question number 1, then question number 11. This arrangement is different. Yes or no?
Yes, sir.
Correct. So basically, if you see here, what we have done here, if I had to choose 2 people out of 25 people, I can do it 25 C2 ways, right? And then I had to arrange these 2 people in 2 different positions, in which, and I can do it 2 factorial ways. Yes or no? That become 25 P2. Yes or no?
Yes, sir.
Correct. So here we have, there are total 15 questions. I had to choose 11 questions, and then I had to arrange these 11 questions, which is nothing but 15 P11 actually. Okay. If you solve this, you'll get 15 factorial divided by 15 minus 11 factorial, which is nothing but 15 factorial divided by 1. Now, are you able to differentiate this combination and permutation?
Yes,
If
sir.
question is
Range
like,
means permutation.
yeah, suppose I'm skipping this question, this part, the blue highlighted part. I'm saying there is a test bank of 15 questions, and the teacher had to select 11 questions. In how many ways I can do it? So then option C will be the correct. Is this clear?
Yes,
No,
sir.
sir.
Thank
No,
you.
sir. No, sir. Not
Yes,
clear.
sir.
Okay, where, okay, why, okay, where you are getting difficulty?
Ma'am, sir, in arranging the questions, why will multiply?
See, arrangement is what? Okay, first of all, tell me whether this one is okay or not.
Yes, sir.
What we are doing here, I am going to select 2 people out of 25, right?
Yes, sir.
Then I have to arrange these 2 people, right? Then I have to multiply it by 2 factorial, correct?
Correct.
Which is nothing but 25 P2. I can use this is directly, or I can do in this way. Anyway, both are the same. Here, what we are doing, I have total 15 questions, correct? Out of 15, I have to choose 11 questions. Then
Correct,
I
sir.
have to arrange those questions, right? Then arrangement, see, if you are going to arrange those questions, then arrangement will be different, right? Order will matter or not.
Yes, sir. Yes, sir.
Okay. For example, suppose there are 3 questions. Okay, let's do for 3. Okay, then I can choose in 3 ways, 15C 3 ways, right? Then to arrange, I can do in 3 factorial, which is nothing but 15P3 directly. I'm writing this again and again to get an idea. to all of you because I mean where this permutation came. Actually, this is the one arrangement you can say, right? For some people, if you see question 2, question 1, question 3, this will be the another. This is the different arrangement, right?
Yes, sir. Yes, sir.
Correct. So this is something meaning of the arrangement. Is this clear?
Yes, sir.
Right. Yeah. What about question number 3? Answer is there, but tell me how.
How many ways can be
Sir, we
four
have
non-identical ring? How many ways?
See, there
Four
are 5 fingers,
non-identical
and you have 4
ring.
non-identical ring. And how many ways you can do?
How many ways four non-identical ring and be within in 5 figures?
Yeah, just think a little bit.
Four non-identical.
See, just think what are the possible places you have, and then in how many you can do.
How many?
Sir, we can do like this, sir. For one ring, we have 5 fingers. So, sir, for second ring, we have 4. Like this, sir, we got 5 factorial at
Yeah,
the
yeah,
end.
correct. Just think. See, for first ring, what is the option? 5 options, right?
Yes, sir.
And for the second ring,
4 options,
for the third ring,
3
Three
options,
for
options.
the last ring,
2.
2
what is this? 120.
Yes,
That's
sir.
all. We have to
Yes.
multiply. Correct?
Sir, we can take 5 before.
See, now what you are doing, you are just memorizing the formula. Okay. So it's good to start with very basic thing, right? Just think how many places you have. Okay. Then what are the options, right? For the first, you have 5 options. For the second, you will be 4. For the third, you will be 3. Correct? It's a simple way. Okay. Okay. So let's move to the fourth question. Answer is 720. That's okay. But just think
How
for 4 to
many
5
ways?
minutes, but tell me how you will get the answer. Okay. I'm going to give you some 4 to 5 minutes. Okay. Just tell me. Because this is something you have to think a little bit.
There is permutation is used, sir.
Whatever is there, just think, just the concept till now which we have discussed. Okay. Just apply and tell me your approach. Okay.
Yes.
We can do including permutation directly, factorial also, combination into permutation, combination into that approach, like I took, right. You have to choose R things out of n, then you have to arrange. Sir, you have to arrange the book. Okay, just think like that. Okay, you can make the cases. Here will be cases. So while you are solving the questions related to permutation and combination, try to do in step. Okay, rather than using just okay, just randomly 5C2 5P2. It's good to go with the stepwise. Okay, just take some 5 minutes and we'll discuss. Okay, and everyone please try it.
So 20 ways.
No, answer is 720. Okay, how did you get this 20? We'll discuss, because anyway, we need to clarify whether you are getting different.
So because
How?
we have 2 bookshelves and 5 distinct books, so I multiply
5 into 2
into 4.
5 into 4. Okay, no worries. Why 5 into 4?
Because sir, we have 2 bookshelves now. So that's why I multiply 5 and 4.
Yeah, 5 into 4. So 5 for what? For book, first book shelf?
No, sir. For first bookshelf, I write 5. And for another bookshelf, I write 4. And then I
Okay.
multiply it.
That's okay. Okay, let me give you a hint. Your approach, okay. For first book, you can, okay, for first book shelf, you have 5 options, right? You can put any 5. In the second book shelf, you have kept 4, right? Now those 4 you can arrange also. Yes or no?
Yes, sir.
That those 4 in how many ways you can arrange?
4 factorial ways.
4 factorial, right? What you got? 5 into 4 factorial, which is?
Yes, sir.
5 factorial, right?
Yes, sir.
Now you have taken only one case, one book in any of the one book in first book shelf. There is also possibility you I can put 2 books in the first book shelf and 3 books in the second book shelf. Yes or no?
Yes, sir.
Correct.
Yes,
So
sir.
just do in the same way, right? Your first approach, first step is okay.
Okay, sir.
Yeah. Okay. Anyone getting the correct answer, or should I discuss?
No, sir.
I mean, you're not getting answer, or should I should not discuss? Discuss, should I discuss? Okay.
Discuss, sir.
Fine. Okay. Okay. Let's try to understand. You will tell me now. Okay. So I have 5 books, right? Correct.
Yes, sir.
And 2 bookshelf. Correct.
Yes.
So there will be cases, right? Just try to see in such kind of scenario, rather than using just randomly 5 to 5 it's good to go with the steps. So what is okay? There will be cases like case one can be like this. It's possible I will arrange 5 books, right? In first bookshelf, correct? Yes or no?
Yes, sir.
And
Yes.
0 book in the second. Yes or no?
Yes.
Yes.
Yes,
In
sir.
how many ways you can arrange these 5 in first bookshelf?
Perfect. Yep.
And 0 a book in second, that is 0 factorial, anyway 1, right? That is 5 factorial, which is
Yes,
120.
sir.
Correct.
Yes, sir.
Now case 2 will be, it's possible I will arrange 4 books, right? In sorry, let's do like this. Okay, let's do like this. 0 books in the first and 5 books in the second. So it will be 0 factorial into 5 factorial, right? Yes or no? Just so reverse scenario, right?
Yes, sir.
Okay. It's also possible I have to arrange first book in first bookshelf, right? And remaining 4 books in second. Yes or no? Now tell
Yes.
me in how many ways you can put first book in first bookshelf. I mean one book.
1 factorial.
1
One book,
factorial
one
1
book.
factorial into 4 factorial.
factorial.
You are not thinking. I'm asking one book. First of all, before arranging one book, yeah, we need to choose one book, right?
Yes.
I can put any of the 5,
5.
right?
5C2.
Yes, sir.
5C2.
Correct. Into, because it's, and what about 4 books in the second? I can do in the 4 factorial ways.
Yes, yes.
Correct? Which is again 5 factorial. Yes or no?
Yes, sir.
Same if you see the case 3, I will be having I can keep 2 books in the first, right? And remaining 3 books in the second. Yes or no? In
Yes,
how
sir.
many you can do the 2 books in the first?
5 multiplied by 4.
5 multiplied by 4, right? Correct? Yes or no?
Yes, sir.
And remaining 3 I can do in 3 factorial.
3
Which is
factorial.
again 5
5
factorial.
factorial, 120 ways.
Are you getting how we are moving? Right?
Yes.
Case 4 will be 3 books, right? In first and
2 books.
2 books in second.
Second.
Right? Which will be again for 3 I can do 5 into
4 into 3.
3
into
2
factorial.
factorial.
Which is again 5
5
factorial.
factorial, 120 ways.
Right? Then case 5 will be 4 books in
second.
First and 1 book in. So for 4 book I can do 5 into
3, 4 into 3 into 2 into 1
which is
factorial.
again.
Yes,
right?
sir.
And case 6 will be all books in first
and
0 book
in second.
That means again 5 factorial into 0 factorial, 5 factorial again 120. So if you see 120 is 6 times, right? 6 cases are there. So 6 into 120, which is nothing but 720. Okay, is this clear? Yes or
sir.
no?
Yes, sir. Yes, sir.
Right?
Yes, sir.
So are you able to get the idea, right?
Yes, sir.
No? Okay, so so this is some activity 6.1. I think anyway, this is some activity questions you have to do to get an idea. Let me do one question from here and one question from the next one. Then we'll. Okay, this arrangement things. Okay, and okay, tell me how many ways you can do. I told you formula. So first of all, what we have to see? Just tell me the approach. What we have to see? What is the total number of letters, right?
Letters.
What is that? 3,
A
3, 6?
number of repeating letters.
No. What is the total number of letters now? 11?
Yes, sir, 11.
It will be 11 factorial, right?
Yes, sir.
Divide by. What is, how many letters are repeating? M is repeating 2 times, right? Then
Yes, sir.
R is 2 times.
R is repeating 2
R is
times.
2
Then
That's also.
G is 2 times.
G is also repeating 2 times. So that
sorry.
means we have to do 2 factorial, 2 factorial, 2 factorial.
2 factorial.
Right?
Yes.
Now tell me about this question. In how many you will do? 7 people are going to sit at a round table. How many different ways can this be done?
7 minus 1 factorial.
6 factorial.
6 factorial. Yeah, 7 minus 1 factorial.
6
So
factorial.
here it is not mentioned clockwise, anti-clockwise, or same or different, but you have to think. See, if people are there, anyway, clockwise, anti-clockwise will be different, right?
Yes.
Okay. So here it will be 6 factorial. 6 factorial means 720, right?
Yes.
We'll see. Cross. What about this question?
8 minus 1.
Just think. It's about
8 factorial.
no. Okay, first of all, if you are saying something, right, don't say randomly in the air, right? It's good to just think a little bit.
We arrange in 7 factorial ways, right? 7 ways.
7 factorial divided
10
by
factorial
2.
ways.
See, 7, yeah, who tells 7 factorial by 2?
Yes, 7 upon 2.
7 factorial by
7
2.
factorial upon. Yes,
See,
sir.
it's if you see, it's a necklace, right? It's
Yes, sir.
beads, right? If you see the mirror image, then clockwise, anti-clockwise will be same, right?
Yes.
So for 8 bits, it will be 7 minus, 8 minus 1 factorial divided by 2. That means 7 factorial by 2. Okay.
Yes, sir.
So if you see the answer for the previous one, it's a 720, right? Because we have to arrange the 7 people on a circular table. So it will be 6, sorry, 7 minus 1, which is 6 factor, which is 720. Now it will be 8 factor, sorry, 7 factor by 2, which is 2520. Is this clear? Right?
Yes, sir.
Yes, sir.
Let me take one more question, then we can. Okay, what about this question? Question number 1. Tell me which thing you will use. Just think. Which formula you will prefer?
Permutation.
Why permutation? Again, I ask. See, when to use permutation?
Order matters.
Here order is mattering.
Yes.
Why? Tell me how order will matter in this case.
It is 3 men and 5 men. Right?
Total 6 and 8 women. You have to form a committee of 3 men and 5 women.
Yeah.
Okay. So to form a committee, what we have to do? I need to select 3 men out of 6 and 5 women out of 8, right? I'm not
Yes.
worrying about order. I need to just select 3 people and 5 women to form a committee. That's all, right? Here I'm not saying who is the president, who is the vice president, or who is the chairman, who is the vice chairman, right? I have to just select. I have to form a committee. I have to form a group of people. That's all. Okay. So we have 6 men and 8 women. Okay. You have 6 men and 8 women. You have to form a committee of 3 men and 5 women. Now tell me in how many ways you will do. Just tell me the formula.
6C3.
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 8C5.
8C5.
8C5. What? Into or plus?
2 into.
Plus.
Into.
Multiply.
Into, not plus.
Sorry.
Here I'm talking about and, right?
And.
Okay. Yeah. Okay. Okay. Let's do the question number 3. Tell me. Just think and tell me what should be the answer.
11 factor 11.
Sir, which question? Second or third?
Question number 3. 3.
The 10C5.
Why 10? I'm asking question number 3.
I thought to.
See, what the basic thing we have to find? Anyone? Okay, tell me, did you get the meaning of the question?
No, sir.
No, sir.
Okay, so read the so what question says? You just got 3 free ticket. Okay, means you have 3 ticket. Just go line by line. On the purchase of 1 ticket, that allows 3 people along with you for a movie. Means you have 6 people who want to come along with you. How many different groups of 3 friends could you take with you? So simply means, see, you can take only 3 people, right? And you have a 6 friend. Correct?
20.
Yeah, 20 is the correct answer because see, basically what we have to choose, how many different groups you can make? Make up 3 friends out of which 6. So basically I have to choose 3 people out of 6. That's all. Right? It doesn't matter order, right? I have to simply choose 3 people out of 6. Yes or no?
Yes, sir.
Yes, sir.
Is this clear
Yes.
now?
Yes, sir.
Yes.
Okay, let's do the very last question, then we can wind up. Anyway, okay. So it's there is, okay, just read and tell me the approach. Answer anyway you can get, but tell me the approach. I need to.
Which question, sir?
Question number 7, last question.
It's 11C3. So 11 choose 5.
C2.
Sorry,
this is
3.
okay.
11 choose 3.
Okay, I will tell you the why you are choosing 11C3. See, but read the condition also. Need to little bit careful in this kind of scenario. See, a box contains 5 red, 4 white, and 2 blue balls, right? 5 red, right? 4 white, okay, and 2 blue, right? Correct. Question: the 3 balls are drawn at random. Find out the number of ways of selecting the balls of different colors. We focus on this statement. If it's okay,
Yes, sir.
if the question is like I have to choose the 3 balls, right? Then I will simply do 11C3. But its condition I have to choose the 3 balls, correct? And all are different color. Yes or no?
Yes, sir.
That
Yes.
means one is red, one is white, and
White,
one is
one is blue.
right. If you see in how many ways you can choose one red ball out of 5C1 and
Multiply
4C1 and
4C1,
2C1, that
2C1.
is nothing but 40. Is this clear? The
Yes, sir.
difference, right?
Yes, sir.
Just read the statement carefully, right? If this is not there, you can simply do that case. Okay. Okay. Is that all right? Okay.
Yes, sir.
Yes,
Fine.
sir.
Okay. So you got the idea of question. Sorry, concept of permutation and combination, and some questions which you have discussed, right? Fine. Okay, so just try to complete the lecture
Yes.
video, okay, before coming to the next session, because only then you will get the some idea. Okay, then we can discuss more on it. Will that be all right? Okay.
Yes, sir.
Yes, sir.
Yes, just try to finish
Yes.
the concept and try to do the questions, and you'll be, if you have any idea, sorry, any doubt, we can discuss on the upcoming session. Okay, fine. Okay, yeah. Okay, is there anything else? So
Sir,
only thing is, just try to cover the content, okay? Only then you will be, I mean, it's good to, if you cover the lecture, then you will be having some doubt, we can discuss more on that, okay?
Okay, sir.
Fine? Yeah. Okay.
Yes, sir.
Okay then.
sir,
Thank you, sir.
Yeah.
sir, there is one question I posted in the chat box.
What is that? Where is there?
Sir, above, sir, I posted an image in the chat box of the question. It's from week 2 actually because I'm not able to join discourse.
Discussion forum you have access?
No, sir, I'm not able to join discourse, so
Actually,
I
it's
can't.
this image is
Same,
not
sir.
opening for me. Can you tell me the question? What is that?
It's just actually a graph question, and I wanted to know what it means by manipulated y-axis.
Okay, can you tell me the question number, and because this is showing me it's not support the file format actually. So can you tell me the question, or it's from practice or where?
Sir, it's actually from week 2 activity question 2.4. There's a
Activity.
graph given there.
One second. Here, little bit. Okay, which graph? Okay, let me share my screen. Okay, which graph? Question number? Which
Yes,
question?
sir, this question only, sir.
Okay, so what is doubt here? What is your doubt?
Sir, I answered missing baseline, but the answer is missing baseline and manipulated y-axis both. So I'm not able to understand what is manipulated y-axis.
Okay, so manipulated y-axis means, so basically we have done some manipulation on the y-axis, right? So if you see, it doesn't see if lower limit is okay. It's not started from some 25 and all, right? Means before
Yes, sir.
30, there is some manipulation on the y-axis, right?
Yes, sir.
Are you getting my point? Okay. So let me tell you something. Suppose this is the x-axis, this is the y-axis. Okay. Suppose I've done the scaling 0, 5, 10, then sudden I jump to let's say 25. Okay. Then 30, then 35. So there is manipulation from here to here, right? Yes or no?
Yes, sir. Yes,
By
sir.
my intention. If zero is not there, you will simply say lower, missing baseline. But if it's not there, right, that means there is some manipulation has been done on y-axis, right? It's not like that. What is from here? 30. If suppose this is 25, 30, that means your lower limit is 35 itself. But it's not like that. Before 30, we don't know how much difference in the unit is there. Correct?
Yes, sir.
One thing you can refer this one, you will get some more idea. There is resources from instructors, so just read this PDF. Okay, there is one PDF you will get, then you will be able to see manipulation by axis means by intention or by something to show something by our intent, something, no, by our intention I am doing some manipulation. Let me tell you this thing. If you see this chart itself, okay, so there is a smartphone A, smartphone B. If you see the first graph, so I can say there is a significant amount number of sales of phone A and phone B, right? For phone B, it's 120. For phone A, it's 80, right? There is only less difference, but significant amount of sales is there. Yes or no? By the first graph.
Yes, sir.
Okay.
Yes, sir.
I suppose you have done some manipulation on y-axis. I mean, suppose you have scaled up to 300. But if you see by a quick at the first loop, if you see to see the bars of A and B, so it seems there is a less, I mean, less number of sales distribution, right? But in reality, it's
Yes.
not. Correct? Suppose by intuition,
Yes.
I have done the manipulation. I have extended the y-axis. This is the another kind of manipulation of the y-axis, right? Okay. So if you
Okay, sir.
see, it seems there is less number of. I mean, it's something is giving is misleading us, right? It's giving me some wrong information. In reality, if you see, it's 120 and 80 itself, but by seeing the length of bars, it seems it's less. Okay.
Okay, sir. Okay, sir.
Okay. Yeah. So you have done
Okay,
some
sir. Thank
manipulation
you,
on
sir.
y-axis. Yeah. Okay.
Yes, sir. And sir, also I'm not able to join this course.
This course, are you qualified student, right?
Yes, sir. No, sir, I'm
Uh,
not qualified. I'm actually in my term 2.
Term two. Okay, then you should be able to. Okay, so okay, what you can do, you can mail me your mail ID. Okay, I will try to add you on this course. Okay,
Okay, sir.
okay, fine. Okay,
Sir,
then
my
yeah,
IIT ID, right? Okay,
yeah,
sir.
your IATM ID. Yeah,
Sir, where to email it?
just mail to me, my mail ID.
Sir, I don't have your email ID.
Okay, just write prasant@study.iatm.ac. Okay, fine.
Sir, could you repeat 1 second?
Just write my name, Prasant, and then study.iatm.ac.in. Okay. Okay.
Sir, could you type it in the chat box?
Okay. What you going to just write to support also? No problem. They will help.
Okay, sir. Okay,
Okay.
sir.
Yeah. No. Okay then.
Thank you.
Thanks, Sola. Okay. Just try to
Thank you,
cover the
sir.
content and try to solve more questions. We can discuss more on it. Okay. Fine.
Thank you, sir. Thank you, sir.
Okay.
Okay,
Thanks.
sir.
Hope you got the idea.
Yes, sir.
You all. Bye.
Thank you,
Bye.
sir.
Thank you.
Thank you, sir.